Hi students, myself Jamuna, working as an associate professor at Nada Engineering College located in Erode. Now I am going to give lecture on solar energy. Before entering to the solar energy topic, first we will see what is the percentage of renewable energy in solar. So as we all know, solar energy is the one of the renewable energy. So the percentage of solar in a renewable energy is 11.5. That is in third place. First place is hydroelectric and then wind, and third is our solar energy. And solar power statistics by country wise, if we see, means China is the first one. Peach color is a total capacity and pink one is a annual installed capacity. In that, China is first one, second one is United States, third one is Japan, and our country is in fourth place. And which countries do not use solar power? So mainly we are seeing the solar energy, that is a renewable energy. Some of the countries were not using solar power, that are Saudi Arabia, Turkmenistan, Hong Kong, Qatar, Oman, Libya, Kuwait and Bahrain are some of the countries that do not yet use solar power in 2025. These countries are not using a solar power for the production of electricity. And some of the countries which has the 100% renewable power is Iceland. Iceland which uses 100% renewable energy power in 2025, and Paraguay, Costa Rica and Norway are the virtually 100% using only a minimum content of fossil fuels. And the biggest solar power plant in the world is located in our country, India. That is Patla Solar Park. That is the capacity of that will be a 2.25 gigawatt. So the biggest solar power plant in the world is located in our country. That is Batla Solar Park, which has the capacity of 2.25 gigawatt. After that we have China, India, Egypt, like that. And we know, usually we know the solar power plant which was located in a land, but nowadays the solar power plant also placed in a water, that is lake water, pond or lake water. So which produce more efficiency, because if it is located in water means that will reduce the temperature. So it produce the more efficiency when compared to the solar power plant located in the land. Now we will move on the basics of solar energy. Solar energy is the solar material, that is our silicon material which captures the light energy that converts that into electrical energy, which was used in DC load directly or stored in battery. If we want to use that in AC load, means we have to convert that by using an inverter. And solar cell, so the construction of solar array or solar panel is made by solar cell. A solar cell is defined as an electrical device that converts light energy into electrical energy through photovoltaic effect. So solar cell which converts the light energy into electrical energy through photovoltaic effect. A solar cell is nothing but our PN junction diode. Individual solar cell can be combined in a module or panel. That gives more voltage and currents. So we are combining the solar cells in series and parallel like that produce modules or panels. The open circuit voltage of a single solar cell will be a 0.5 to 0.6 volt. And this is the structure of solar PV cells. In this, already I said it's a PN junction diode. So it has a P-type material, below that N-type material. In between that has its depletion layer. Above that it has a glass layer and silver fingers. And below that it has a metallic contact. So this is the structure of solar cell. So in that we have, if you see that structure means it has many parts. In center part it has solar cell, and above that encapsulant EVA and tempered glass and aluminum frame. Below that also we have encapsulant EVA, backsheet and junction box, like that. So single solar cell has these parts. And construction and working of solar cell is, so if the solar cell, single solar cell is exposed into a sunlight means, when the sunlight hits on the solar cell means, that means the sunlight has photons. So if it hits on the solar cell means that produce the electron hole pass. So if that electron moves outside to the load means that produce the flow of current. So basically a solar cell is nothing but a PN junction diode. So when photon hits on the solar cell means that produce the electron hole pass. If the electrons moves to the outside side, that means load means that is our electricity. This is the photovoltaic cell, module, array and panel. So this is single cell. If the single cells is connected in parallel or series, to get more voltage means the cells will be connected in series. To get more current means the cells will be connected in parallel. So if we connect the cells in series and parallel means that will give module. And again if the modules are connected in parallel means that is array. Again that will be connected in series or parallel means that is our panel. Photovoltaic solar power system. So already we know the solar cell works on photovoltaic principle. That means photovoltaics directly converted solar energy into light energy. So the solar cell which converts the light energy into electricity. The principle is nothing. This principle is called as photovoltaic effect. When the certain materials are exposed to the light, they absorb the photons and release free electrons. So that material is our silicon. When we expose that silicon into light means that absorbs the photon that produce the free electrons. And this phenomena is called as photoelectric effect. And the photovoltaic effect is a method of producing direct current electricity based on the principle of photoelectric effect. Based on this photovoltaic effect, our solar cell which produce the DC power. Criteria for the materials to be used in solar cell will be, how we have to choose a solar cell is, must have band gap from 1 electron volt to 1.8 electron volt. So that is the band gap means the gap between conduction and valence band. That gap will be a 1 electron volt to 1.8 electron volt. It must have high optical absorption, which means it has to absorb light energy highly. And third one is it must have high electrical conductivity. And fourth one is the raw material must be available in abundance and cost of the material must be low. So when we take silicon means it will be available abundant. So we use silicon as a solar material. So already I said this, we are using silicon material as a solar cell. It is also the second most abundant material on the earth after oxygen. The solar cell made out of silicon currently provide a combination of high efficiency, low cost and long life. Why we are using a silicon means it is abundantly available, it has high efficiency, low cost and long life. Modules are expected to last for 25 years. The lifetime of the modules will be 25 years or more, still producing more than 80% of the original power after this time. So up to 25 years it has lifetime. After that also it produces 80% of efficiency or power. Semiconductor materials for PV cells will be a silicon cells that can be a crystalline. The silicon cell, we know our solar cell is made up of silicon material. That silicon cell may be a crystalline. The crystalline will be a monocrystalline or polycrystalline or thin film. Thin film is amorphous silicon. So usually our silicon cells are made up of, it may be a monocrystalline, polycrystalline or thin film. Thin film materials used for flexible lightweight solar cell, that means cadmium telluride, a common and efficient thin film material. A common and efficient thin film material is cadmium telluride, and copper, indium, gallium diselenide is another well established thin film material, and amorphous silicon is another form of silicon material. These three are CDTE, CIGS and ASI is the thin film material which was used in solar cell. So monocrystalline and polycrystalline solar panels. So monocrystalline which was in black color and polycrystalline which was in blue color. So we see some of the solar panels are in black and some will be in blue. So depending upon the material, the color will changes. And the comparison of monocrystalline and polycrystalline panels are, if we see the cost wise means polycrystalline is less expensive when compared to monocrystalline, and in efficiency wise monocrystalline is best, that has more efficient than polycrystalline. And aesthetics, that has solar cell, that means the color wise, the monocrystalline is black hue and polycrystalline is bluish hue, and lifespan both are 25 plus years. And temperature coefficient, monocrystal has low temperature coefficient, more effective when temperature changes. High temperature coefficient, that is polycrystal which has high temperature coefficient, less effective when temperature changes. And this is the perovskite semiconductor material. This is the structure of the perovskite semiconductor material. So the nowadays the perovskite materials were used. The perovskite material typically consisting of lead or tin based components allows them to absorb sunlight effectively across a broad spectrum, improving the cell overall efficiency. So perovskite, if you use perovskite material means that gives more efficiency. This is the thin film, that is the comparison of these three solar material, silicon material, that is monocrystalline, polycrystalline and thin film. So we know some of them, we know this news. IIT Bombay incubated a startup, advanced renewable tandem photovoltaics India has developed a, so the IIT Bombay developed a 4-terminal silicon cellular cadmium telluride perovskite tandem solar, that is silicon cadmium telluride perovskite tandem solar cell with a conversion efficiency of 29.8%. So we know the efficiency of solar will be at less than around 20 to 25%, but they developed this perovskite, one of these perovskite solar cell which has the highest efficiency of 29.8%. This was developed by IIT Bombay. And this is the this curve represents the solar cell IV characteristics and then voltage power characteristics. So if you see the IV characteristics, the I is in y-axis and B is in x-axis means, so when voltage is increasing means the current remains constant. At certain point, if we increase voltage means the current decreases. So at a particular point both voltage and current will be maximum, that is called maximum current and maximum voltage. On that point we will give a maximum power, that is the MPP, maximum power point. So on certain point, that is the drop in curve, on that point we will get maximum voltage and maximum power, that is our maximum power point. So in y-axis, when the voltage 0 means that on that point we will get short circuit current. In x-axis, when current is 0 means on that point we will get open circuit voltage. And this is the solar's IV characteristics when cells are connected in series. When the cells are connected in parallel and series. When cells are connected in series means we will get more voltage. Series connection means that increase the voltage. When cells are connected in parallel means we will get more current, which was shown in this diagram. And some of the parameters in solar cells are open circuit voltage, short circuit current, maximum power point and fill factor. So first we will see open circuit voltage. This is the maximum voltage that the array provides when the terminals are not connected to any load. So when the solar cell is not connected to any load means that gives the maximum voltage, that is your open circuit voltage. This value is much higher than the VMP, which relates to the operation of PV array, which is fixed by the load. And second one is short circuit current, the maximum current provided by the PV array when output connectors are shorted together. Open circuit voltage means when there is a no load means that will give the maximum voltage. When the output terminals are shorted means the solar cell which produces the short circuit current, that is the maximum current which is higher than IMP. And maximum power point, this relates to point where the power supplied by the array that is connected to the load is at its maximum value, where maximum power point is IMP into VMP, the product of IMP and VMP. And last factor is a fill factor. This is a very important factor. The fill factor is the relationship between the maximum power that the array can actually provide under normal operating condition and the product of open circuit voltage multiplied by short circuit current. So the formula for fill factor is nothing but fill factor equal to P max divided by VOC into ISC. The fill factor value gives an idea of quality of array, and closer the fill factor is 1, the more power the array can. If the fill factor is 1 means that array will produce more power, and its typical value will be 0.7 to 0.8. And percentage efficiency, we know the efficiency is nothing but output power by input power. Here the output power is electricity and your input power is solar irradiance hitting on the array, that is your input power. So if you take that ratio of that two means we will get the efficiency. The efficiency of typical solar array is around 10 to 12% depending upon the monocrystalline, polycrystalline or amorphous or thin film materials used. And this is the solar energy chain. So you know, first silicon, which is the abundant material, and that is converted into vapor, again that is converted into cell, again that cell is made up of into module, again the module will be converted into a assembly kit which was used in our home or any other industry, and again we are recycling that material, again that will be converted into silicon. This is the solar energy chain which we have seen. Next one is a equivalent circuit diagram of a solar PV cell. So this is the equivalent circuit of single solar cell. So in this we have one current source in parallel with a diode, and RSH is shunt resistance and series resistance. So the current source is when the photon hits on the, that is the when light energy hits on the solar cell means that produce electrical energy, that light energy is represented as IL, and diode is connected in parallel means, which means the silicon it is similar to our PN junction diode, so that is represented as this diode. And RSH is nothing but the diode leakage current will be represented as RSH, and RS is resistive loss, that is the PN junction diode resistance and metallic contact resistance which produce some losses, that loss is represented by RS. So this is the equivalent circuit of a single solar cell, and V is our output voltage, I is our output current. So from the above diagram, if you see, we can write the output current equation, which is nothing but IL minus ID minus ISH is nothing but our I, output current. So I is output current, IL is photogenerated current, ID is diode current, and ISH is shunt current. So ID we can write it by using a diode, Schottky diode equation formula, and ISH is shunt current, which is nothing but V by RSH, and IL is light generated current. And we know cell to module to array. So single solar cell, already we have seen this. Single solar cell can be connected in series and parallel means which produce a solar module, and which will be connected in again series and parallel means we will get panel, and again this will be connected in series and parallel means we will get solar array. So if they ask draw the solar cell characteristics for a 2 cells or 4 cells which is connected in series or parallel means you can draw it. For example, if they given short circuit current as 5.8 like that, in this curve assume the short circuit current as 5.8. The single solar cell open circuit voltage will be a 0.6. So if you draw that means you will get first curve. If the 2 cells are connected in series means that the voltage will be 1.2. So 5.8 to 1.2, that is the second curve. If 4 cells means 2.4 like that. If 10 cells is connected means we will get 6 volt. If 20 cells are connected in series means we will get 12 volt. So we can draw the IV characteristics for different combination of cells. And this is for modules. If one module is there means if the current will be 5.8 and voltage will be 12 means that is the first. If it is two module means 5.8 into 2 you will get 11.6. So that is the two modules and the voltage will be 12 because that two will be connected in parallel. Again three modules. So if you see this diagram means that three modules will be connected in parallel. If parallel connection means the current only increase, the voltage remains same. So if single module, the current will be 5.8 and voltage 12. If you connect two module in parallel means the current will be 11.6 and voltage will be same. Again three module also. And this is the module to array. This is for one module. If two modules are connected in series means you will one module 12 volt. Two modules are connected in series means we will get 12 volt, that is two module in series. And six modules means six modules in parallel means we will get this curve, third curve. The last one is the advantage and disadvantage of solar cell. We know advantage of solar cell is no pollutant because it's a renewable energy. It must last for a long time and there is no maintenance cost, but initial installation cost is high. That is one of the disadvantage of solar cell, and it has low efficiency. And during a cloudy day the energy cannot be produced, and also at night we won't get a solar energy. If you use battery means we will get. So these are all the disadvantage of our solar energy. So now so in this video I have covered what is the renewable energy produced in India and other state, and the working principle of solar cell and materials used in solar cell, and characteristics of solar cell, and then equivalent circuit of solar cell, and finally we have seen the advantage and disadvantage of solar cell. Thank you.